domain? And when does it fall apart? All right. So we've got our models, right? So I'm going to use to the nearest whole number. So I'm going to use my linear model of y equals 293x minus 4695. So what we're going to do is we are going to predict how much oil for 1996. And then we can go back. We knew the exponential model gave us over 80,000, and that was way off. So when I plug in 96 for x, let's see what we get for our y value. This looks pretty good. Now I've got 23,433 millions of barrels. That's much better. That's a much closer prediction compared to the actual. So the actual was 23,360. The predicted was 23,433. So that is far more reasonable, right? So when we're looking at our domain for our exponential regression versus our linear regression, if I look from 1905, right, when we started, if we're looking at our exponential, where would you say we want to stop? When does it stop becoming meaningful for our prediction? Probably, yep, I agree. Yep, 1980, that sounds good. Nice job, Ryle. So, our X is the year. So, and I'm going to include 1905 to 1980. So now, if I'm looking at the linear model, I know it worked out pretty well for 1996, right? I don't know if it's going to work much beyond that. And then, well, we stopped at 1980. If I look at my data, though, they went up by every 2 years, so I'm going to say 1982. So there's my domain ranges. This is where it's meaningful. All right. So this is going to kind of try to pull things together. So when we went back to Mitchell and we looked at the, when we were given 2 points, problem 81, we were given 2 points and we used y equals ab to the x. And we did our substitution, right? Sometimes we could do an elimination, and sometimes we needed to do a substitution, but we could find A and B. And we ended up, for those 2 points, we came up with this equation. He's wondering if he could use the regression functions on his graphing calculator to determine the equation of exponential functions. So what does he mean? And will it work? So he's wondering if he could put the 2 points into a list. So put the 2 points and then go to number 0 and select exponential regression. All right, so give it a shot. So take out the graph calculator, go into list 1, list 2, make sure everything is cleared. You don't want any other stuff messing you up, and see if it would in fact work if we just had 2 points. All right, so what do you think? Did it come out okay? Oh, awesome. Look at that. So much easier. It works Way to go. We got the same prediction. So now he's looking, well, is it going to work for linear equations as well? So give it a shot. If I've got 2 points, right, I could look at my delta y over delta x. The difference between 729 and 144 is 585. The difference between 6 and 2 is 4. That one was pretty good. So I've got, let's see, now I'm gonna, it goes 146 and a fourth, or 0.25, one left over. There we go. So that's our equation. So if I've got y equals mx plus b, let's say I'm going to go with the smaller numbers. 144 equals 146.25 times x, which is 2, plus b. I double it, subtract. I'm going to get a negative, oh, okay, negative 148.5 for b. So does it work? Totally works, right? When you're looking at your yay. All right, so I've got my equation y equals 146.25 x minus, what was that? Oh, minus 148.5. Okay, now down the bottom, we do have the math notes. So this is just the equal value method when I'm doing, if I would like to, this is a little bit easier. If you have y equals a b to the x, right? If you take your y, if you solve for a, you're going to have y over b to the x. That has to equal the other value of y over b to the x. So all they did here is they looked at your two equations here and they said, okay, so 14 equals a b to the second, and then they said, well, 112 equals a b to the fifth. So if this is 14 over b squared for a, this would be 112 over b to the fifth for a. When I set these two values equal, I think this is often easier to solve. It's your choice. You're going to have a few strategies. When I go to solve for these, you can just multiply. I take whichever one has the bigger exponent in the denominator because I like a positive exponent. I multiply both sides. So now I have b to the third, right, times 14 equals 112. I can divide by 14 and then take the cube root, and I'm going to get b to the third. This is equal to 8, so b equals 2. I'll stick it over here. I have every confidence you can plug that in and solve for a, right? 14 divided by 2 squared, 14 divided by 4, I'm going to get 3.5, right? 7 over 2 is 3.5. So this is going to be the hard part that comes up on at the end of the exam, the unit test, is when you're given 2 points and you have to find that exponential equation. If you can remember way back one in M3 or M2, and you were given 2 points and you had to find that linear equation, that used to stress you out and it was a lot of work, and now it's nothing. So you're going to get there. Same thing with a linear equation, exponential equation. You're going to do your substitution, you're going to have some different strategies, and you're going to look for the easiest path. All right, that's all I got for you. It's quite a bit. Make sure you practice with your graphing calculator, and we'll talk to you soon. Bye-bye.